All right, we're going to take a look at this problem here. Binomial probability, Jake beats Marco at chess 70% of the time. Assuming this probability is constant and the games are independent, meaning that winning one game doesn't change the next game, change the probability at least. What is the probability Jake will beat Marco in at least 16 of their next 20 games? So this is a binomial type problem, and you can tell that for a couple of reasons. So first off, if you wanted to make a tree diagram of this, of Marco and Jake beats Marco 70% of the time. So supposing they play one game, he could win or lose 70-30. And then the second game, supposing he wins the first one, he could win or lose the second one. And so the options don't change. The tree diagram would be very large because you're playing 20 games. So it would be sort of 20 levels large. And therefore, there's a better way to do this. And that is binomial probability. So that must two things must be true. The 70% can't change. It can't, and that is this independent statement here suggests that the 70% will stay 70% throughout this tournament. And then the other thing is that's important is that there's really just two options, winning and losing. And thus the by, meaning two nomials, you only have win or lose as the option. So this falls under this category. We can apply the formulas to solve this problem a little quicker than a tree diagram. We need here to win at least 16 of the next 20 games. And that would mean, I'm just going to make some notes to myself here. He could win at least. So, okay, this phrase, at least 16 means he could win 16, but that would be the least. So he could win 16, 17, 18, 19, or all 20 games. And that's a lot of different combinations of things to win. So we're going to figure out probability of each of these particular outcomes happening and then add them all together. So to start us off, let's get this is our random variable here. X, capital X, is going to represent the number of wins. And so the first calculation to make, probability that X equals exactly 16 wins, is, let's see, we've got wins. That's the win probability, 70%, and therefore loss, 30%. We want, in this example here, we're going to have 16 wins. So this is going to happen 16 times 0.7 times 0.7 times 0.7, somewhere in the tree diagram, 16 of those, which means 4 losses. Okay, those add up to 20 because you're playing 20 games. Now, how many branches is tough to count. So that's where we lean on our calculator to help us out. The notation for doing this, we're going to play 20 games. We want 16 of them to be the win games, and that implies the 4 is the loss. So that we can calculate. That's 20, choose 16, and let's go ahead and fire that up here. Let's try to get it not in the shadow. Let's clear all that. It's 20. We go math, probability, 20, choose 16. So out of the 20, 16 are going to be the wins. There's 4,845 ways to win 16 of the games if you don't care which 16 they are. And so this notation represents the number 4,845. And we're going to take that, multiply by this to the 4th, and 0.7 to the 16th. We'll do that all in one. So let's go ahead and get that number. It's 0.3 to the 4th, 0.7 to the 16th. All right, about 13% chance. I'll just round it for the sake of kind of keeping things relatively straightforward. 13% chance of winning exactly 16 games. Now the question says at least 16, so we're going to repeat this process for 17, 18, 19, and 20, and then add the results of that together, which looks like this. Probability X, capital X,